warahmatullahi wabarakatuh. Hello everyone, I'm Nabila Andriani. My student ID number is 21029096. I'm a student of Padang State University. Today, I want to explain to you about limit. Have you ever heard about limit before? The first topic is history of limit. Archimedes of Syracuse first developed the idea of limit to measure curved figures and the volume of a sphere in the 3rd century. By carving these figures into small pieces that can be approximated, then increasing the number of pieces, the limit of the sum of pieces can give the desired quantity. Archimedes' thesis, the method, was lost until 1906, when the mathematicians discovered that Archimedes came close to discovering infinitesimal calculus. As Archimedes' work was unknown until the 20th century, others developed the modern mathematical concept of limits. Englishmen Sir Isaac Newton and German Gottfried Wilhelm von Leibniz independently developed the general principles of calculus, of which the theory of limits is an important part in the 17th century. The second topic is basic idea about limit. Limit, mathematical concept based on the idea of closeness, is primarily to assign values to certain functions at points where no values are definite, in such a way as to be consistent with nearby values. The word limit comes from English, which means approaching almost. Accordingly, if we say that x is close to 3, then the value of x is only close to 3 but never to 3. The general form of the limit of an algebraic function is the limit of f(x) as x approaches a equals L. Next, properties of limit. There are 10 properties of limit. First, we will assume that the limit as x goes to a of fx and the limit as x goes to a of gx exist, and that c is any constant. Then, first, the limit as x goes to a of constant fx equals constant the limit as x goes to a of fx. In other words, we can factor a multiplicative constant out of a limit. Second, the limit as x goes to a of fx plus minus gx equals the limit as x to a of fx plus minus to the limit as x goes to a of gx. So, to take the limit of a sum or difference, all we need to do is take the limit of the individual parts and then put them back together with the appropriate sign. This is also not limited to two functions. This fact will work no matter how many functions we have got separated by plus or minus. Third, the limit as x goes to a of fx times gx equals the limit as x goes to a of fx times the limit as x goes to a of gx. We take the limit of product in the same way that we can take the limit of sums or differences. Just take the limit of the pieces and then put them back together. Also, as with sum or differences, this fact is not limited to just two functions. Fourth, the limit as x goes to a of fx over gx equals the limit as x goes to a of fx all over the limit as x goes to a of gx, provided the limit as x goes to a of gx doesn't equal 0. As noted in the statement, we only need to worry about the limit in the denominator being 0 when we do the limit of equation. If it were 0, we would end up with a division by 0 error, and we need to avoid that. Fifth, the limit as x goes to a of fx upper n equals the limit as x goes to a of fx all to the n. In this property, n can be any real number such as positive, negative, integer, fraction, irrational, 0, etc. Sixth, the limit as x goes to a of nth root of fx equals nth root of the limit as x goes to a of fx. Seventh, the limit as x goes to a of constant equals constant. Constant is any real number. In other words, the limit of a constant is just a constant. You should be able to convince yourself of this by drawing the graph of fx equals x. 8. The limit as x goes to a of x equals a. 9. The limit as x goes to a of x to the n equals a to the n. This is really just a special case of property 5 using fx equals x. The third topic is example of limit. I have a question. Evaluate the limit as x goes to 2 of 8 minus 3x plus 12x squared if it exists. There is not really a lot to this problem. Simply recall the basic ideas for computing limits that we looked at in this section. We know that the first thing that we should try to do is simply plug in the value and see if we can compute the limit. So the limit x goes to 2 of 8 minus 3x plus 12x squared equals 50. How about this? Evaluate the limit as z goes to 8 of 2z squared minus 70z plus 8 all over 8 minus z, if it exists. There is not really a lot to this problem. Simply recall the basic ideas for computing limits that we looked at in this section. In this case, we see that if we plug in the value, we get 0 over 0. Recall that this doesn't mean that the limit doesn't exist. We will need to do some more work before we make that conclusion. All we need to do here is some simplification, and then we will reach a point where we can plug in the value. So the limit as z goes to 8 of 2z squared minus 70z plus 8 all over 8 minus z is minus 15. The last one, the limit as x goes to minus 3 of square root of 2x plus 22 minus 4 all over x plus 3, if it exists. There is not really a lot to this problem. Simply recall the basic ideas for computing limits that we looked at in this section. In this case, we see that if we plug in the value, we get 0 over 0. Recall that this doesn't mean that the limit doesn't exist. We will need to do some more work before we make the conclusion. Simply factoring will not do as much good here. So in this case, it looks like we will need to rationalize the numerator. So the limit as x goes to minus 3 of square root of 2x plus 22 minus 4 all over x plus 3 equals 1/4. And the last one, application of limit. First, it helps to measure the strength of the magnetic field, electric field, etc. Second, limits are used to figure out the most relevant pieces of information from the large complex functions. Third, limits are used on the derivative. A derivative is a rate of flow or change and can be computed based on some limit concepts. Fourth, limits are key to calculating integrals, expression of areas. The integral calculates the entire area of small pieces of it. Fifth, limits are part of the iterative process. An iteration is repeatedly performing a routine, using the output of one step as the input of the next step. Each output is an iterate. Some successful iterates can get as close as desired to a theoretically exact value. That's all for our presentation today, and I would like to thank you for your time and attention. Assalamualaikum warahmatullahi wabarakatuh.